Okay, testing. All right, so this video here is sort of picking up from where we left off. Appian image comment part 4 recursion function general Python explanation. So go create the video nữa and bây giờ tao để nó mua để nó thì này là sai để nó nữa thì này mà nó tao mua and so họ nói thì nếu thật sự có Python script nữa đó generate each results coming back from the database in a dictionary, and then normally take the most current one, whichever one it is. They take the most current comment, and then the one nữa là giờ the whole comment nó thì normally print out. This is new print out còn level đó thế gì thế là thì normally thì cho mình nhọ. For example, e nó thì nó mình the first one here. ID1 이제 more parent ID1 no ID1 no 이제 auto 민요죠 auto no right two children here references this parent one. As you can tell, number 3 here is referenced by this one and the one down here, right? And so whereas number 4 here is the parent of this one down here. This one down here is the child. And so it draws out something really interesting at the bottom. And let me see if I could move to it, find it, locate it, or something like that. Down here, if you go down here, then you print the first comment on it, you reply to first comment, another reply to the first comment, another reply to another reply to the first comment, a reply to another reply to the first comment, stuff like that. And there's only Facebook, which we'll call it Facebook's messengers reply, and so the smart way to do it is if you use Python to generate you sort of like an idea of what you want to build first. And then of course you use Appian to build it because the solution is obviously within within Appian, is not within Python, right? So what we want to do is we want to build comments, and then we want to build comments to comments of comments to comments of comments, whatever it is. And so we have two tables here, entity and comment. Okay, so entity and comments here, you got to make sure um, the primary, the parent comment ID is whenever that's specified, the parent ID is not specified. So it's either this one or it's either this one. It can never be both. Okay, so bây giờ relationship này thì bây giờ bữa thì có mua khó sống nó thì khó cá nó ok là popular ok là nhiều chủ mua nhiều khó. For example, khó for key constraint này thì it talks about this. Khó nó mà nhiều chủ mua là gì khó nó mua sự khó nó mua chỉ lại nó nữa ok. Thì khó bây khó check prevent that from happening okay. This check bây khó reference check integrity check nó it says that this and this both of these cannot be populated at the same time. So I insert a bunch of records into both tables, okay, such that you have a sort of a hierarchy, right? Sort of a hierarchy where you create this one references the first product or something, and then the second one, and so forth, right? So nó mua khó thì mua khó comment một cái khó product, tức là nó mua tiếng hình tế cho comment để có comment nữa thiệt, cho mua tiếng hình tế cho comment có comment cho khó product nữa thiệt, cho mua tiếng hình tế khó khó comment of khó khó là tế rồi khó comment tôi khó là tế khó comment tôi khó là tế khó comment tôi khó product nữa thế này then the tao level right thì bây giờ print nó out. This is what we have here so far, right? So here we copy this from the previous video, not just copy, but we actually built this. We reconstructed this in the inside of Appian, such as this function here is actually being called down here. So there's a recursion. Um, there's a recursion here such that we're calling this one time, right? We call this one whole time. Let me delete all this junk. So we call this one whole time. We pass it in this value and then this value here, and we pass it into this. What this is going to do is Nuhulu database, right? And then Nuhulu database to populate, for example, all comments right here, right? And you can tell there's 47 records here in the database that nó support thì rồi thì tiếng hình tế tua lớp tài luôn thì tiếng hình tụ một khó tiếng hình tế nó multiple level nữa, right? So so what we do is we built this we populate test data into the database, and so for example we're looking at the first comment with ID 1. So what it's gonna do is it's gonna take this one here. It's gonna look at this one right here, and then it's going to it's going to take that and make that into this comment. Okay, this comment right here. This one, take this one, right? This one here is stored inside of this comment here, right? But all comments here is stored by way of a query record here. Query record here pulls all of the information into all comments here, but we have to convert it into a list of maps here so that we can tap into the data much more easily. And then what you have is you have, again, comments here as I've described, okay? And then you have children comments, okay? So literally children comments here is we're trying to find all of the children for this comment here. And as you can tell, there's only one here right now, right? There's only one children here. Well, actually, let's not dig too deep into this because forget about what I just said. We know that all comments here and this comment here, and then everything else underneath here is kind of like fuzzy. All right. So the thing about this is that all comments here, we're going to try to find all of the children of this comment, right? And this comment can change. This comment could be like this comment or this comment, and it's looking for like any children that has the parent comment of 10, right? So this one's 10, and that's it. There's no more 10, right? So, or maybe there is. We gotta look for it. No, there apparently is not. So what it's gonna do is gonna try to find all children of this comment. And then what it's going to do next is it's going to make a list of children comment lists, and it's going to look at this comment. It's going to say, does this comment exist or not, right? This actual comment, right? We don't know. So if it does not exist, then nothing happens, okay? But if it does exist, then you have what's called, then we take that comment and we say, yes, this comment has children, and then we populate, we add this comment, right, to this list here, right? And then when we add it to this list here, we have created a node in the largest scheme of things. as we bring one on mic get there okay to call how comment no more minua na ya no more minua te be yo be out to not to ho te be chu to o lu to to nu be chu tian ni tan tan de minua to la cho do hong no right so so what we do is we add benzi to comment no gata do shong no okay so what I want to do is probably name this something else because it doesn't make too much sense to me as I'm reading it. Um, so maybe we call this one um, maybe we call this one like comment list or comment order list, something like this, right? So comment order list here, we're going to um, append this comment into the comment order list. Okay. And so what happens here is we're going to continuously um, add this comment to the list in the order in which we there's a bunch of think about it no more data whole database and we want to order it, right? Maybe we call this one hierarchical, right? Order or hierarchy. Let's say, for example, I want to hierarchy. Let's call this one comment hierarchy. Okay, we'll call this comment hierarchy because this is a reorganization of data. There's a bunch of data in the database that we have to order it in the right order to make a lot more sense of it, right? Imagine this the data nên đâu should be đâu nó là this is bây giờ tao muốn nữ cho là cho ấy còn nữ một quá cho tụ tụ tin hình sai nữa nè, right? Thì giờ tụ tin hình sai nữa chứ nếu sai thì nếu sai thì nó mua nó tao cho nó nè, thì sai thì nó thì một quá thì mua meeting nè, okay? Thì có chân sẽ thì nhóc bộ nó sẽ đi sắm anh chế cái một số xì nó nè, okay? So còn nó mà chỉ bảo thì lý trả lên nè, còn nó mà nhiều sẽ bị đỡ đâu tới nó đó, đó là comment this chỉ trong nó nè, comment nó mà đi trong trở nên nó nè, yeah. So comment hierarchy nó chỉ bên gì trong của nó, right? So I just want to make sure we could test this out and be on the safe side because this does take some thinking to be able to do. So, for example, how comment hierarchy nó chỉ bị reorganize the data structure nó còn như trong câu thì bây giờ tao create a memory location hoặc the comment hierarchy thì the comment nó chỉ mua thì biết what là chỉ sự nó nè, đó là the họ mua thì bây giờ chủ muốn người chạy cho họ chơi hoặc the comment hierarchy nó nè. Thì tập biết chạy ta lỡ nó chỉ biết mà đi lo qua họ nó tao một ok thiết nó họ nó thế họ nó mà xí hiểu bị được ok nữa. So reason for họ bottom piece nó nè is very important. It is like saying we know that we're gonna try to get all of the children comments and then we're going to loop through the same instructions here, right? The same instructions here because this is IC test recursor, right? Recursion. IC test recursion, which means that There's a comment ID here. As you can tell, there's a comment ID up here. We're passing all this into it, right? There's also a level here, right? So it's very important to understand that hey, there's a level here, right? Um, so here's so in other words, it's going to take the first child, each of the child, right? Depending how many there are. If you have the chimo minyo the tali okay, da the shi the mo minyo the so much pass itu minyo la tong no la. The to minyo ha di na the ni nya ro no. Ha level the ni nya ro no. 是什么还跌都没有老的很多跌都没有要 this comment 了条，这老是吃的都没有不莫名有天喏，那这莫呢这莫的去莫了要的这边喏呢，哎你也好 comment 呢，这你说的 OK 这也好 comment 这边莫呢这么在到 comment hierarchy 喏条，right? And then it's going to say 要的莫名有这吃的这么有天喏，可能这吃的这么有呢，要的。Say here, look through. Okay, so this is apply this rule to each children, right? So, so I say, I think we can just say here for construction of hierarchy, right? Making sense of linear data, right? So make sense of this is an example of like linear data here. Like linear data is just flat data. There's no like meaning behind it as much as there are hierarchical data, hierarchical hierarchical hi, hi, hier, hierarchical data. So I can't even say that word. Hierarchical data. Hierarchical data has depth, right? Whereas linear data is just a bunch of crap data, like not crap data, but a bunch of data just thrown into the database for speed and performance, et cetera, right? Which maps to each other in sort of child and parent relationship. It's called, in other words, it's called hierarchical or self-referencing. Okay, so that's where you come in here and you have you pass in the first ID and then you look through the whole entire thing and then you say, is there any children that I need to process as well? And then if there's not, then you're done, right? And you can literally go through all of the hierarchies, right? So for example, if we created this here, the hierarchy, this is the hierarchy here, okay? Another hierarchy. So what we could potentially do is we could loop through all of these in sort of a way that it goes through all of these. You know, it goes through 1 through 2, 3, 4, 5, all the way to 47. Um, in this example, though, we're only looking at the first record. The first record. So imagine if we wanted to run this through. We could potentially create a new expression rule, and we could say the beginning, or maybe beginning or mass recursion or something like that. It sounds really cool, right? Mass recursion. Mass recursion is another word of saying mass processing of this shit. So, say for example, if you got a list of all comments here, right, and you want to like, you could literally pass in all of the IDs into this function here, and it'll generate you massive shitload of information, like the entire structure of existence, if you wanted to call it that. Boom. Here, so we got a bunch of all comments here, and then we know that for each comment we want to call for each items, and then we want to say local bang all comments and expression. We want to do a fv item um, dot. Then we want to make sure that we understand that we're trying to pass in the ID into this, along with sort of like maybe perhaps we local local level, right, is 0, and then we want to increment this every single time. So for example, we might want to say FE item index, um, FE. This is probably the index, right? Because yeah, this is probably the index here. We'll just call it the index, right? So in other words, we have to call this function here. This is the index because we're assuming that for each index is incremented properly items, right? Or actually it's called comment ID and then level um, here, right? So I don't know what's gonna happen here, but it might blow up. I don't know. But as you can tell, all we're doing here is we're collecting all of the comments here. We're going through each one, and we're calling this this recursion. And within this recursion is actually another call of the recursion itself. So hopefully we don't blow this shit up. Okay, so here we are. Let me save this. So keep in mind you have to save changes here so that it can call itself. It can call the new version of itself. So let's see what this does. Boom. Oh my God. Okay, the output, look, even if it says the output is too large to display, so the so this value has been truncated. Switch to raw and expression from raw. Oh my God. Yeah, this is quite it has to go through all of that. Go to raw, you got 86 hierarchical um, like comments of comments of comments of comments type deal here. So I would say it's pretty accurate because check this out right here. This is 5. I can't even click on it. Okay, so this is what the hell? Okay, so here parent comment is 1. This is comment 1, 2, right? This is the comment of 2. So it's kind of cool because you can pretty much build a freaking hierarchy of data using this and be able to display the sort of like the data structure, the depth of the data structure, and so forth, right? So that's kind of cool. Again, as I've stated, right, this hierarchical data here is looking at like really sophisticated data structure. The idea behind one of these things is that you only want to display the right amount of information because there's going to be too much information here to process. And so as you can tell, all this almost took like 751 milliseconds, right? So you got to be careful with these because these could tear down your system. Uh, Imagine calling a function within a function and this really non-deterministic, or probably I wouldn't call it non-deterministic. but it's that we don't understand where the end is. We just let the application just run freely to solve the problem. So imagine that you only want the parent nodes from this, right? Well, the parent nodes is relatively easy. You can just get all the commits and just say, these are all of the hierarchy at the top. That's it. You know, and all of the comments is there's only about 47 of them. You know, so you could drill down further. Um, Say for example, if I only wanted to know the first one, right? If I really just wanted to know the first one, I could just do something like this. I could just go um, test case, ad hoc test case here, and I would just say, well, I want to know the 39th something. If there is such a thing, and if there is, then it pops up. Yeah, 39th. 39th only has one child response, which is 47, right? So obviously you can have more data. Suddenly, like somebody comes in here and they want to comment. They want to comment on 47. Then 47 becomes the parent of that comment. You know. So this seems to be working nicely. Uh, the idea with this is that eventually what we could do is we could say that for example, product one. Product one. Um, what we could also say is that for product one, we want to see all of the comments, right? But what if product one has too many comments? I I don't think that's like an issue at all. But it could be that what if this one has like a couple thousand comments? Maybe you might want to break things down further, perhaps. I don't know, but there could be other strategies. But for now, we know that we can add things to it. You know, we could add um, just like we could even break things down further. We could just say, hey, if this child is at the um, third level, then let's not add this child to it. You know. So we can do some if condition here, even at the append, right? We can even do that. So um, imagine if you had okay, you had one, right? This is probably at a different level. And also not just that, but you could also uh, design even a different data structure for this, right? You can even generate like a map, right? Let's say, for example, a bang map, and then you say um, a bang map. Let's say, for example, let's do a level. Let's do a level, right? Let's do a R level, and then we do something like um, comment here, right? Like we could even do something like this, where we're actually appending more details into this, right? So imagine if I save this, um, hold on, let's make sure that we're not screwing up ourselves here. Oops, I think we are. So let's go back to this map here. Let's take this. Let's leave this. Let's go down here to this. And let's pretend that we are appending this. All right, so let's, oh, actually we have to test, so we have to save this first. Now, let's test the rule. And notice that we do have levels now. We have level 0, and then we have the comment, and then we have level 1, and then we have the comment here. And I could very well say that, hey, look, truncate at level 5. That's too much, or truncate at level 4 or something like that. So now we have additional information into this map here. Um, and so that's how you do it. That's how you build really advanced data structures that you're generating this. So that eventually your application can just consume this by generating the graphics for it, or like the card layouts, or like the replies, or like the icons and stuff, right? Okay, anyways, that covers the recursion for this piece of the puzzle. The next one, we're gonna implement the UI with our data structure that our hierarchical comment hierarchy data structure.